Today we're going to talk about angle pairs. We're going to talk about supplementary angles, complementary angles, talk about linear pairs and vertical angles, and how all these angles work together to make a roof truss like this thing behind us here, which are good for holding roofs up so it doesn't fall in on us. So let's get our angles down so we can hold that roof up. All kinds of angles here that we've got to investigate, and so let's get some names down here so that we can talk about things and work with these pairs and do a lot of stuff with them. So first kind of pair that we have is complementary angles. All right, complementary angles are two positive angles whose measures have a sum of 90 degrees. So if we look at our angles, let's see if we got any complementary angles over here. Complementary add up to 90 degrees. Now in this roof truss, there's a 90-degree angle right here. Remember this. So this little box means 90 degrees here. We put this little square there. So if that's 90 degrees, then, and we know that we have a straight line here, then these two would have to be 90 degrees. I'm going to put 1 and 2. So let's say angles 1 and angles 2 are complementary. So not a compliment like they're really nice to each other, but you know, this guy says, hey, you're right. No, you're right. No, you're right. No, we're both right. See, they like to compliment each other. So, all right, corny joke. So complementary angles add up to 90. Then we have supplementary angles here. Supplementary are angles that add up to 180 degrees. So supplementary is going to have a sum of 180 degrees, or we say two angles are a supplement of each other. All right, so if we look here, we've got some angles. These two guys right here are supplementary. They happen to be 90 degrees, it looks like. I'm going to guess they are, but they do add up to 180 because a 180 is a straight angle there. So like 3 and 4 here are supplementary. Now, to be supplementary, they don't have to be connected. You can take two angles like this 115-degree angle and this 65-degree angle. They are supplementary. These two angles we know are supplementary because they're connected, and we'll have another name for that in just a moment. So complementary, 90 degrees, supplementary, 180. Or we can say this. Suppose we got angle 1, and it's the complement of angle 2. Well, angle 1 is 62. So how big is angle 2? By the way, this little m right here means the measure of angle 2. Find the measure of angle 2. Well, we know the measure of angle 2 plus 62 is 90. So if we subtract 62 from both sides, we can find out that our angle is 28 degrees. Because complementary means they add to 90. Well, if we got two angles that we know are supplementary, remember, supplementary adds to 180. Complementary was 90. All right. So we want to find the measure of angle 3 if 3 and 4 are supplements, and angle 4 is 47. So we know that the measure of angle 3 plus angle 4, which is 47, has to be 180. And if we subtract 47 from both sides, we're going to get 133 degrees. Okay, so complementary, supplementary. Great. Well, we got another type of angle, and that is adjacent angles. Complementary and supplementary angles can be adjacent or non-adjacent. Adjacent angles have a common vertex and a common side. Okay, so they're connected. They have a common vertex and a common side. Okay, these two are non-adjacent here because they don't share a side and a vertex. You can have another, let's say there's an angle and there's an angle. So angle 9 and 10, let's say. Those two angles are connected at a vertex, but they're not adjacent because they don't share a side. So we've got to share a side and a vertex. Do we have some here? Well, yeah, those angles 3 and 4 there are adjacent. So these are supplementary and adjacent. Okay. And they're adjacent because they have a vertex in common. These two angles there. Let me draw that in a little bolder maybe. So we've got this angle 3 is this guy here. And angle 4 is this one here. So 3 and 4. All right. Let's look at a couple other little angles here. We got angle 11 and angle 12. These guys don't add up to 180, but they are adjacent. They share a vertex and a side. So we can say that angle 11 and angle 12 are also adjacent. Okay. Now, you can be adjacent like these two here. These are adjacent, okay, but I can have another pair of angles like this. So here's two adjacent angles, and they're not supplementary. All right, so, all right, you can be one or the other or both even. So we got one more, actually two more pairs here. And these two pairs will show up all the time. We're going to use these guys a lot. The first pair is called a pair of a linear pair. So two adjacent angles. First, they got to be adjacent. They're called a linear pair because, let's see if I can spell, a linear pair because they make a line. So you may think back to algebra where we had linear. We talked about linear equations, and linear means they make a line, all right? So two angles are a linear pair if they make a straight line. And so here we have two angles, angle 1 and angle 2 are a linear pair. So first they got to be adjacent, which means they're connected, all right? And then they together make 180 degrees. So since they make a straight line, and we know a straight line is supplementary, it follows, and this is actually a theorem. This is called the linear pair theorem, our first theorem that we will run into. The word theorem means something that we can prove. So we have the linear pair theorem says that linear pairs are supplementary. So a lot of vocabulary going on here. Linear pair just means the two angles that make a straight line. They're connected and they make a straight line. Supplementary means they add up to 180. Now, if you are a linear pair, then you have to be supplementary. But if two angles are supplementary, they don't have to be a linear pair. Because remember, some supplementary angles are not connected. All right, so we might have two angles kind of like this that, well, they look like they add up to 180. Let's pretend they do, but they're not a linear pair. So the moment you know they're a linear pair, then we know that they are supplementary. Okay, then we have a very special pair of angles. Two angles are vertical angles when their sides form two pairs of opposite rays, okay? So here we have a bunch of angles, actually. And so if we take this pair right here, this angle 4 and this angle 5, those are vertical angles. They are opposite of each other. Their sides are opposite rays. Then if we take this angle 3 right here, that's this guy right there, and this angle 6, that's this guy right here, those guys are also vertical angles. So vertical doesn't necessarily mean up and down in this case. It means straight across. You can think of it that way. So, and we run into another theorem here that's worth talking about for a second here. If you look at these two angles, like angle 3 and angle 6, you might ask yourself, which one seems bigger? Which one seems smaller? Or do they seem the same? And what about 4 and 5? Do their measures seem like 4 is bigger than 5, or is 4 smaller than 5, or are they the same? Well, it does turn out that they're the same, and we will dig into proving that sometime soon. And this is a theorem, but vertical angles are the same or they're congruent. So it's important, and we'll use this all the time, that vertical angles are congruent. All right, great. Well, we've got two angles, linear pairs and vertical angles. Let's see if we have any of those in our truss over here. Linear pairs, two angles that make a straight line. Well, we have these ones that are kind of a reflection of that other one. These two are a linear pair, so I don't know what we're up to. We're up to probably 6 and 7 here. So that's a linear pair. And then vertical angles, we don't really have any vertical angles here because none of the 2x4s go through it, okay? So I suppose maybe if we wanted to build on like a dormer window here, you know, like a little window here, whoop, whoop, then this angle right here, 8, would be vertical angles. So angle 6 and but that's a bit of a stretch. All right, great. Well, there's our angles, and we'll leave it at that. We have, again, a little review. Complementary angles add up to 90. Supplementary angles add up to 180. Adjacent angles are connected. They have a share a side and a vertex. And some of those adjacent angles are a linear pair if they make a straight line. And vertical angles are opposite of each other. So, angle pairs, very important, very useful. And we'll see how we can apply those to things like a roof truss.